Since the middle of the last century, an astonishing building material has had unsurpassed success: the sandwich panel. Modern industrial buildings without sandwich panels for roofs, walls and doors are now almost unthinkable. Today's industrial architecture is significantly influenced by this superior building panel. What are the reasons for this success story? First of all, the exceptional physical properties, superior strength and unsurpassed insulation, and the excellent product quality. In addition, the economical installation of the panels, regardless of wind, weather or season. Finally, there are the low building costs and short installation time, which make this product a real winner. Our film shows how these proven and superior sandwich panels are produced economically and in the highest quality on Simple Camp double belt plants. We want to show you production with two typical lines. Sandwich panels for walls and roofs are produced on this line, and sectional garage door panels on this one. On both lines, galvanized and pre-painted steel sheets are used for production. The production starts with uncoiling the material. Two uncoiling stations, one each for the upper and lower strip, are installed. Protective films are applied to the upper and lower steel strip to protect the high-grade surfaces until they are installed on the construction site. At coil and color changes, this station comes into action. The end of the running strip is securely connected to the next coil with rivets. It's important that production continues without stopping. Another form of strip connection, apart from riveting, is widely used: clinching, which is almost like riveting, but without rivets. On this line, the side of the strip material is trimmed to the required width. Immediately after the roller slitter, the cut-off strips run into the chopper. The chopped scrap is automatically transported in a scrap bin. A surface structure can be applied onto the steel strip before profiling. Embossing rolls with various patterns creates a surface with a special appearance. Besides the popular structures of lining, stucco and wood grain, the lower strip, for example, can also be profiled with a micro rib. Where panels are produced for garage doors, the steel strips are cut out for locks and hinges. Encoders linked to the process computer guarantee a precise production sequence and exact positioning of the cutouts. As you have seen, two loops are integrated in this area to ensure a continuous production flow. The Corona treatment station greatly enhances the adhesion of the foam to the inner strip surface. This has recently become more important for more critical foam systems like PIR foam and CFC-free blowing agents. We now come to the hydraulic embossing press. This press stamps a special decor into the door panel. Here it's cassette motifs. This station is particularly essential for the excellent look of the panel and finished door. The downstream edge profiling unit is exceptionally important for the quality of the finished product. Precise production of the strip's edge profile generates an exact sealing fit from panel to panel. To profile complicated profiles, such as pinch-free edge designs, requires quite a high degree of sophisticated profiling skill. It's obvious that the steel coating must be of the highest quality to prevent any traces of this deformation torture being visible on the steel. Let's move to the profiling of roof and wall panels. Here it's the beginning of the upper profiling for the inner side. After the spraying devices are several sets of profiling rollers which form the shape of the panel profile. The edges can be formed to a straight tongue and groove profile or to a visually more appealing hidden joint or secret fix profile to hide the screw. Whichever profile is produced, keeping the closest possible tolerance and preventing any damage to the surface are the prime objectives of any profiling machine in a Simpelkamp line. Now let's take a look at the profiling of the lower strip. Later, this is the outer side of the finished panel. The forming of this profile is necessary to increase the rigidity of the roof panel for high loads. A view from below shows how this panel will appear later on the building. The steel strips now run to this part of the line, where the upper and lower strip form a sandwich panel together with the core. We first fill the panel with a mineral wool core. Sandwich panels with a mineral wool core are specifically produced for building projects with higher fire protection requirements. Special prefabricated mineral wool slabs with vertically oriented fibers are used in this line. A thin film of glue is applied to the leading edge of each slab during cross-transport to form an endless strand from the single slabs. This way, one slab is bonded to the next one and an endless panel is created. A uniform film of glue is applied to the complete surface of the upper and lower strips with oscillating spray mix heads. A linear stream of glue is extremely important to reduce the amount of glue and to prevent any overspraying. The mineral wool core is seamlessly bedded in this glue. An alternative method is to use standard mineral wool slabs with horizontally oriented fibers. Simpelkamp also supplies special production lines to produce mineral wool cores on line with vertically oriented fibers. Trapezoidal filler strips are cut with angular saws and rotated into the right orientation. These filler strips are transported into the roof strip in the main line and fill the empty ribs. Here, strips are cut from mineral wool which form the mineral wool core of the sandwich panels after they are rotated. This sounds somewhat complicated. Why follow this method? Well, typically the fibers in mineral wool are oriented horizontally, which is an unfavorable orientation for use in structural building panels. To achieve a satisfactory compressive strength, the fibers should preferably be oriented in vertical direction between the upper and lower strip. This can be achieved with strips cut to size and rotated. All the strips are placed in a staggered position to each other to increase their strength and then formed to an endless panel. Now let's return to the regular production sequence. You remember the upper and lower strips were already profiled. Now the sheets come into the preheating station. At this point, it's crucial that both strips are precisely heated to achieve the best possible adhesion between foam and steel skins. For polyurethane sandwich panels, a mixture of several components is used, such as polyol, isocyanate, activators, various additional components, and a CFC-free blowing agent. The chemical components necessary for this process are stored here. It's obvious that plant output and tank storage capacity are related to each other. The components are pumped from the tank storage to the metering and pre-mixing machine. Mass flow meters exactly evaluate the throughput of each component. Plate-type heat exchangers with liquid heating units heat the components polyol and isocyanate to the exact processing temperature required. The calculated throughput values are sent to the main control computer. All production parameters, such as throughput, pressures, temperatures, recipes and production speeds, are constantly monitored and ensure the quality of the panel. Various Windows-style on-screen menus display the production and process data for a clear and easy interface to the operator, who can input and change data directly on the computer. Let's continue with the process line. Here, the core between the preheated strips is filled with polyurethane. 2 mix heads are installed, which can be changed on the fly. If one is due for clearing, the second mix head instantly takes over the foaming process without plant stop. The mixture of all components is evenly applied to cover the complete width of the bottom strip. The applied foam reacts and expands instantly. The panel is now entering the double belt. This is, so to speak, a continuously moving mould in which the foam cures to the final width and thickness. Various paper or sealing strips are filled into the panel sides to seal it in the curing process and later installation. The production capacity of the plant is, among other factors, determined by the length of the double belt. Side sealing paper and sealing strips can be applied on each side of the double belt to separate the curing foam from the machine and to increase the appearance and sealing capabilities of the panel edge. Sealing of the panel joint becomes more and more important in order to meet stricter energy-saving demands. The smooth, pitch and polygon-free motion of the double belt slats, together with their precise manufacture, guarantee a scratch-free and clean product surface. The ducts, which are visible above and to the side, are part of the double belt's heating system. We continue with the saw. The now fully cured panel is cut to length to customer order, naturally, automatically, and fully computer controlled. Cutting of the panel in continuous production requires that the saw equipment, whether circular or band saws, are precisely synchronized with the product speed and cut at the right point. The innovative new Zimpelkamp saw generation guarantees the smallest possible length tolerances and short cycle times. Rebate cutouts for roof panel overlapping are cut with an independent and flexible diagonal saw. An automatic breakout device later removes the rebate automatically. This provides a clean and tight overlapping installation of the roof panels. Garage door panels are straight cut with a circular saw, which provides an excellent cut and a longer lifetime than a bandsaw. With the new generation of Zimpelkamp saws, even a third saw blade with automatic saw blade positioning can be added for panels for small cold rooms. All Zimpelkamp saws have one thing in common: greatest flexibility in the production process together with high reliability. State-of-the-art plant and process visualization systems provide an operator-friendly and safe control interface of the production process. This equipment allows comfortable and secure plant operation and an instant and flexible reaction to customer order requirements. As a matter of course, the complete saw station, as well as the complete plant, is controlled by the latest and most sophisticated PLC and computer control systems. Back to the production process. The production line is equipped with a modern panel stacking plant. The panels are gently picked up with vacuum cups and precisely turned and stacked in the production sequence. Whether the panels are put on